Good afternoon. My name is Marissa Ortiz. I teach the secondary science classes for Jenison Innovation Academy and UTech Prep Academy. Just wanted to give you an overview about how the labs work here at JIA and UTech. In general, most of our labs incorporate virtual simulations, interactives that they can click through, media-based demonstrations. Generally, those are videos either recorded by myself right here in the lab or found from like the American Chemical Society, for example, um, for them to analyze. There are a handful of at-home investigations. We don't want families going out and purchasing materials for these labs. This would be truly everyday materials such as water, soap, olive oil, etc. I meet live or synchronously with students once per week. Given our time zone differences, we are very flexible about students not attending those synchronously and watching recordings of those. In addition to those recorded sessions, there are generally really concise instructional videos that I provide for students to walk them through procedures in the simulators themselves with troubleshooting tips or walk them through common challenges that students have had in the past. I have one physics example here. This would be Unit 3. We do a projectile motion. And so this is an example of a simulator that we use, and we often use PhET simulators. These are nice because we can toggle variables very specifically. For example, students are tasked with trying to identify whether air resistance or the factors that cause us to ignore air resistance, or perhaps there are scenarios that we don't have to, or we cannot ignore air resistance. So this is a lab exploring those. So they have the option to toggle on and off air resistance. They can change the angles, they can change the diameter of the cannonball, and look at that. Air resistance is definitely a factor there. So there's also tools that they can use to capture data, and they put this data into a table and do some analysis afterwards. So this is an example of a simulator that we use quite often, just for one particular lab. In another example, I have a lot of information here, but these three columns are some phases that we are fairly consistent through science courses. Students generally have a lesson reading that they start with some background information. Then we have some sort of laboratory launch, whether that is my recording during the live session or an additional recording that I have made to help students either get started with the lab, or perhaps I'm walking them through tough questions that students have had difficulty with in the past. Here is an image of the lab itself that they fill out. This is a picture of one of the pages on the simulator, just going to show this is one of those things that you click on and the data will come up for you. In this particular lab, they were investigating how acceleration, the centripetal requirements are. We need to keep those in mind as we're designing roller coasters. So the ride is thrilling, but not fatal. After they submit their labs, in about 2 to 3 days, so about 48 to 72 business hours, I will provide them feedback directly on their labs. And so students open their gradebook. This particular student doing very well, lots of green, we like that. But these purple circles indicate to them that their teacher has left them feedback. And so below that is just an example of some of the annotating that I can do directly on their labs to give them feedback. This is a biology example. Similar concept to the PhET simulators, just a different platform this time around. We've got our lesson reading and our recording posted in there to get them started. This particular investigation requires them to look at predator-prey relationships among food webs and kind of toggle whom eats whom. And they are provided data over time through graph information about how the quantity of those organisms change. And they're asked to glean or infer how energy flows through ecosystems from their data. This is next week's lab, so I do not have feedback or corrections for students quite yet. There are other platforms that we use too. There are labs that we can host through a virtual space that really incorporate a workbench, which is quite nice. In this particular lab, biology students are analyzing the anatomy of stickleback fish, so we might make inferences on their evolutionary history. So they have tutorials about how to score these fish. They click on their tray of fish that will move them to the microscope. So sort of walking students through the steps of what they would be doing at a workbench. Really letting them zoom in, getting those scientific descriptions of the views that they're looking at, whether lateral or ventral view. They score 20 of these fish and create graphs and make inferences or analyze them. This is just a final example of what a physics student might see when they open up a lab folder in their course. I typically have a video assistance to get started, then the simulator that they would use, the lab itself, and sometimes I will include images with quick tips if it doesn't really require a whole video for it, if it's just a quick little thing they need to know. So I hope you found this helpful. If I did not address anything that you are still wondering about, or if you have any questions at all, please don't hesitate to reach out to me. My email is mortiz@jpsonline.org. That's M like Mary, ORTIZ, like zebra, at jpsonline.org. Or you can get a hold of Tahira and she can get a hold of me as well. So thanks so much.